So this is section 5.1. This is triangle sum properties. This is from the worksheet that you will find on Google Classroom. What you can see right here is that we have a bunch of different parts of a triangle that we can kind of identify. We have sides of a triangle, we have vertices of a triangle, we have interior angles, and we have exterior angles. Now, a lot of those things you guys should be able to just kind of figure out. Like, I think you would be able to understand what sides are, I think you'd be able to understand what vertices are, and I think you'd be able to understand what interior angles are just based on what we look at. Now, I think a lot of you will be able to say, well, exterior angles, that means outside because of what we talked about earlier in the chapter. But just knowing exterior angles or knowing the name of exterior angles, sometimes that's not enough, and sometimes that makes it kind of tricky. All right. So the way that we're going to look at this first is we are going to go through by little parts. All right. The first thing that we're going to go through, or the first part that we're going to go through, is what a vertex is. So a vertex, or plural vertices, are these points right here. Notice how I am actually circling the corner of the triangle as well, because that is what a vertex actually is. A vertex is a point on the triangle. So a vertex is a point on the triangle. And no, that is not a D, that is a triangle. So a vertex is a point on the triangle. So a name for a vertex would be like A, or B, or C. So a name of a vertex would be like point A, or B, or C, something like that. Now you should be able to figure out very quickly from this that we can then name sides. We can name sides the same way that we've always named them, but the sides are just these, right? They're these parts of the triangle. And they go all the way from endpoint to endpoint. So the way that we would label these is we would say AC, and we would put a little bar over top of it. We would say CT, we would put a little bar over top of it, and we would say AT, we would put a little bar over top of it. These are the sides. All of the sides are just the parts of the triangle that are actually creating the triangle. Now that should be something that's very straightforward. I don't think that that's an issue that a lot of you are going to have. All right. The last one that's really, I guess, familiar to you, or should be familiar to you, are interior angles. That would be this thing, and this thing. They're angles on the inside of a triangle. All right, those are angles on the inside of a triangle. So that means that we are talking about angle A, angle C, and angle T. So we're talking angle A, angle C, and angle T. And we can actually only use one letter for these, unlike what we've been doing for the last several weeks. The last several weeks I've been telling you need to use 3 letters, but this one I only need to use 1 letter because there's only 1 letter for each of these spots. Now, if there were multiple things that we were looking at, or multiple angles, multiple vertices that are located at a certain spot, then I wouldn't be able to do that. So I have to be able to look at this, and I have to be able to see exactly what I'm talking about when I say each individual letter. So if I said angle A, you have to be able to look at A and say, oh, yep, I'm talking right in that spot right there. If I said angle T, I have to know where I'm looking at. All right. So if I had a different triangle located on here, like if I had another triangle that looked like this, I couldn't say angle C anymore because angle C has 2 angles that are going to it. So I wouldn't be able to say that. Then the last one is exterior angles, and this one's a lot trickier. All right. This one isn't one that we use very much, but this is one that can pop up now and then. So just make sure you know what it is. So what an exterior angle is, it means if I were to take this line and extend it. So see how I've just taken line TA and I've extended it? This thing right here is an exterior angle. So that's an exterior angle. I could do that with every single one of these. So I could extend that line. This is an exterior angle. And I could do that with this line down here. I could extend it. This would be an exterior. All right. So I can do that with every single one of these. I can extend the line, and that's what makes an exterior angle. The easiest thing to do when you're making exterior angles is just pick one of the lines. It doesn't matter which one you're dealing with, so it doesn't matter. If I wanted to do the other line, I could. So like with this, if I wanted to pick the other line, see how I'm here? I could pick the other line and go straight. This would be an exterior angle. It doesn't make a difference. All right. Any questions on what you're looking at right there? All right. So let's go back and let's look at the next part. This next part is all about This next part is all about classification. What did I do? Did I just move this? So let's go through some classifications with this to make sure that we understand what's going on. So these are specific names of triangles. These are names that we can use for triangles. So if I give you the name like an isosceles triangle, you should know what that is. If I give you a name of like a scalene triangle, you should know what that is. So I'm going to try my best to draw this. It's not going to be pretty because I have to draw on a little mouse pad thing. So if you are questioning what it actually looks like, then make sure that you let me know, okay? There are 3 ways to classify a triangle by sides. The first way is called scalene. The second way is called isosceles. And the last way is called equilateral. Now, one of these words you should know. You should know the word equilateral. You should not necessarily know these 2 words. All right, but this one you should know because we've used it in previous chapters. Scalene triangle means no congruent sides. Every single one of the sides is different. So I would have a side like this, a side like this, and a side like this. All of these sides are different, all right? So the way that I can also mark that so I can be positive that they're not the same is I can put 1 mark here, 2 marks here, and 3 marks here. That shows you that they are not the same. All 3 of those sides are different from each other, okay? An isosceles triangle has 2 equal sides, or 2 congruent sides. And I don't know if I have a picture of that here. I do. So an isosceles triangle could look like this, where it's perfect, right? It's just 2 sides are the same. This side and this side are the same. This side is different. And then finally with equilateral, an equilateral triangle has 3 congruent sides. And I can try to make that one happen here too. But with an equilateral triangle, I have 3 sides that are all the exact same. So I would just put 1 mark, 1 mark, and 1 mark. So you should be able to tell whether something is scalene, isosceles, or equilateral by looking at the sides. If you can see that sides are the same, you would either call them isosceles or equilateral, depending on how many sides are the same. If you see that they are scalene, that means that none of the sides are the same. All right, by angles, here's how you can classify them by angles. You can say that they are acute. So you can say it is acute, you can say it is right, or you can say it is obtuse. Now you already know what all of these means, okay? This one means all angles less than 90 degrees. So every single one of those angles would be less than 90 degrees. So like either of these pictures that I drew down here actually would be okay. But every angle is less than 90 degrees. So as you look at this picture, notice how every single one of these is less than 90 degrees. It means that every single angle here cannot be a right angle or bigger, okay? With a right angle, it means one 90-degree angle. So a right angle is one 90-degree angle. So we can draw a picture of that and it looks like this. We can't have more than one 90-degree angle. We can only have one. But that one 90-degree angle will tell me that it is a right triangle. Okay, this is a right triangle. And finally, the last one is obtuse. And obtuse just means one angle bigger than 90. So one angle bigger than 90 degrees. All right? And then I can draw a picture of that, and the picture would just look something like this. So you'll notice that this angle is now bigger than 90 degrees because it's bigger than the corner of a piece of tape. So that's what an obtuse triangle looks like. Any questions on that?
So the obtuse angle has one side that's bigger than 90, but the rest...
Not a side, an angle.
Yeah.
Yep. It
So
has
what's the
one,
difference between obtuse and right?
the difference between an obtuse and right.
Yeah.
A right triangle has this 90-degree angle here, and an obtuse triangle has this angle right here, which is bigger than 90 degrees.
Okay.
All right. Okay, so let's go through a couple classifications together, and then I'm going to go through these theorems right here, just so that we can kind of talk about what's happening. So that we can talk about what's happening with an angle, okay, or a triangle, okay? So let's work through, it doesn't matter. Let's work through something like these four. Now this is 4 different questions, okay? This is 4 different questions. I'm just choosing these, and it wants us to classify the triangle based on what we see. Oops, I actually chose 2 that are the same. Hang on, I don't want to do that. Let's do this. So these are meant to be relatively easy. These are meant to be things that you can just look at and identify within 10 seconds. That's kind of the goal here. All right. So the first thing that I'm looking at here is I see that I have a side length of 4 meters, a side length of 4 meters, and a side length of 4 meters. All 3 of these sides are the exact same. So we will call this equilateral. Now we don't have any markings at all for any of the angles on here, but I can tell based on the picture that this is acute, this is acute, and this is acute. So I could also say that this is an acute triangle. I really can't tell much based on the pictures here. I can't really assume, but just for practice, I can say that this is acute, and this is acute, because if I were to hold a sheet of paper up to that picture, I can see that that's not a right angle, all right? This next one, I can obviously see that I have a right angle marker right here, so I'm gonna call this a right triangle. And I can also see that this side length and this side length are not the same. And I can also see that this side length are not the same. I can see that all of those side lengths are not the same. So I could also call this a scalene triangle. So I could say that something is a right scalene triangle if it looks like this, because obviously this angle is a right angle, and these sides, none of them are the exact same. This one right here, I can't see anything about the sides at all, but I can see that one of the angles is obtuse, so I'm just going to say that it's obtuse. This one right here, I can see that the sides have lengths of 4, 5, and 6, which means that they are all different, so I will call this scalene. Now again, these ones down here, I can't really do much more because I don't have a picture to go off. All of the ones up here I was able to do because I had a picture to go off of as well. Down here, I didn't have a picture to go off of, I just went off of the angles. Okay? Any questions that you guys can think of right now? Any issues or concerns? All right, let me do the theorems real quick, and then once we get done with the theorems, I'll be all done, and I'll let you guys kind of work through a couple questions together because you should be able to do everything on the back of the page. All right, so these are the theorems. We're just going to complete the pictures, and we're going to complete the equations and yada, 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 everything that goes along with it. All right, so the triangle sum theorem, okay? So this is something that can be really, really easy, and it can be really, really difficult based on what you know about a triangle. Every single time that you have a triangle, and I tell you what do the angles of a triangle add up to, your answer every single time, no matter what, should be 180. A triangle adds up to 180, the end. That's what you should say every single time. So the triangle sum theorem is the angle, the sum of the measures of the interior angles of a triangle is 180 degrees. So no matter what, the sum of the measures of the interior angles of a triangle is 180. What that means is that all of the angles inside of a triangle equal 180. So this, if I do this, and I just label these as angle 1, oops. If I label these as angle 1, angle 2, and angle 3, I would say angle 1 plus angle 2 plus angle 3 equals 180. Oops, these are beats. So I would say angle 1 plus angle 2 plus angle 3 equals 180. I don't care what it says in here at all. If I'm ever asked to add up the insides of a triangle, it always equals 180 every single time. No matter what, if you add up the insides of a triangle, then it equals 180, all right? So the measure of the exterior angle is the measure of an exterior angle of a triangle is equal to the sum of the two non-adjacent interior angles. Now this is tricky, all right? So what this means that if I have a triangle and I have an exterior angle on that triangle. So if I have a picture that looks like this thing right here is the exterior angle. If I have an exterior angle and I call this angle 1 and this angle 2, angle 1 plus angle 2 is equal to the exterior angle. Okay. Now this one is not super important and we're not going to deal with it because we can figure everything out about that. So I'm not going to worry about that. And then this one also is not that important. So I'm going to cross that one off too. In a different year when we have more time, I would go over that a little bit more. But this year we don't have as much time, so I'm not going to go over it as much. Okay. So this might be, these two might be something that pop up eventually that we can kind of talk about, but right now I don't really want that to be a big issue or a pressing issue for us. Do you guys have any questions about the triangle sum theorem or the exterior angle theorem?
Exterior angle. So that basically that means that an exterior angle is equal to the two non-adjacent angles. So let's say that we had like the exterior angle equaled 80, then the two non-adjacent, so like the bottom one and the side equals 80 because each one would be 40, correct?
Well, yes, essentially. They don't both have to be 40, but they would have to add up to 80, yes.
Yeah, because you could have like a 30 and 40.
Correct, exactly. Yep, it could be 30 and 50, it could be 20 and 60, it could be 40 and 40, whatever.
Okay.
As long as it adds up to 80. All right, let's go through an example of each of these, and then the rest of this is just going to be your homework, okay? Because all it is, if you look at it, is literally just algebra. That's all it is, okay? So what I'm going to do is I'm going to go through and I'm just going to add up and figure out these problems. So let me go through this. I'll pick these two problems at the same time. So here, all of these are interior angles. Every one of these is inside the triangle. Same thing with this one. Everyone is inside the triangle. The way that I see that is the 35 is inside, the X is inside. All of those are inside the triangle. So they're interior angles. Remember, interior angles of a triangle add up to 180. So I'm going to do 35 plus, I don't know what X is, plus this angle right here is 90. And that's going to equal 180. All of those are going to add up to 180. And this is exactly like a problem that you would have done 2 days ago. Okay, so 35 plus 90 is 125. So I'm going to do X plus 125 equals 180. I'm going to subtract 125 from both sides. And I'm going to get X equals 55. So that tells me this angle right here is 55 degrees. This one right here, I don't know what any of those angles are, so I'm going to say X plus X plus X equals 180. So 3X equals 180, divide by 3, so I get X equals 60. All right, and that's what we're dealing with, okay? That's what you have to be able to do. Now the exterior angle one, that's a little bit trickier. Tiny bit trickier. So this one right here, let's look at this angle, or this triangle. There. And if we look at this one obviously we can see that Y is an exterior angle. So I can see that the Y is an exterior angle right here. Now, that being said, I remember in the exterior angle theorem that y, the exterior angle, is equal to the non-adjacent angles added up. So y is going to be equal to 70 plus 88. So y is going to be the same thing as 158. And that's it. So that's what you guys are expected to do. I want you guys to try and finish that worksheet. We might go through a couple more examples of something tomorrow to make sure that we understand everything that's happening. But right now, you guys have 13 minutes to hang out and practice this. So if you think that you are perfectly capable of doing all of this on your own and you don't need me for help, you can back out of the Zoom. If you don't think that you're okay and you think that you are going to need help, then hang out in the Zoom for a little bit, okay? Make sure that you try a couple questions and ask some questions to make sure that you understand what's going on, all right?